Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we are going to discuss some basics of a very important factor that actually affects the structure and properties of organic compounds. We want to discuss today inductive effect. In order to understand the basics of inductive effect, let's have a look at what we call as the polar and non-polar covalent bonds. We know that covalent bonds are formed in order to get valence shell completed by a way that is called as the sharing of electrons. If a covalent bond exists between two similar atoms, both the electrons are expected to be present exactly in between the nuclei of the bonded atoms. By taking into account the wave nature of electron, we can say the electron density of this single bond, that is always a sigma bond, this remains exactly in between the centers of the combining atoms. That is, this is symmetric. This electron density is always symmetric. If we want to cut this electron density by through a plane exactly in between the nuclei of these joining these two atoms, this electron density will be cut into two equal halves. So we will say as much electron density this is towards the hydrogen atom on the right side, as much is towards the one that is on the left side. So this bond, as a result, gives equal electron density to both the bonded atoms. So this is a non-polar covalent bond. Similarly, if we have another example, like we have two chlorine atoms, they are bonded together through a single covalent bond. The electron density of these two electrons is evenly distributed between the nuclei of the bonded atoms under the normal conditions. So this bond is also a non-polar covalent bond. Now if we take another example, suppose we have a molecule of HCl. Here, these are two different atoms. When atoms are different, there are many things that are different between these two. So one of these is their power to attract the electrons towards their nuclei. And here by electron we mean the shared pair of electron. Suppose the shared pair of electron between these two atoms we suppose that this is distributed evenly. This should be the case because out of these two electrons, one was provided by each of the two atoms. But because of the electronegativity difference, or the power by which this atom could attract the shared pair of electron, this is different. So this electron density will no longer remain symmetrical in between the nuclei of these two atoms. Rather, this electron density will move more towards the atom that is more electronegative. Here we see that the power of chlorine in order to attract the shared pair of electron toward itself is far more greater as compared to the power of hydrogen. The result is that this electron density, this will move more towards chlorine as compared to hydrogen. Now what will be the result? The result is, if we want to cut this electron density into two halves, we see that more electron density this is towards chlorine as compared to the share what hydrogen gets. So as a result, this bond is a polar bond. And when electron density moves more towards one atom, that atom acquires a slight negative charge. And the other atom acquires a similar amount of the opposite charge, that is positive. So in this molecule, more electronegativity is shifted towards chlorine as compared to hydrogen. So chlorine becomes negative but partially, slightly negative, and hydrogen equally partially positive. So this partial negative means that there is no actual charge on this chlorine, rather this is a fraction of that charge. Now let's we take another example from organic molecules. Suppose we have this simple compound, that is ethane. It has 7 sigma bonds, one between carbon-carbon atoms and 6 bonds between carbon and hydrogen. Now the bond between carbon and carbon is between two similar atoms, so the electron density is understandable. It will be evenly distributed between the nuclei, so this bond will be a non-polar bond. But the bond between carbon and hydrogen, this is between two different atoms. Their electronegativities are different. But remember that the bond between carbon and hydrogen is always considered non-polar under normal conditions. That is, for hydrocarbons, this bond will be non-polar bond. That is, the electron density is evenly distributed between the nuclei of the bonded carbon and hydrogen. Similar case will be on the other side. But if we take another compound, that is, suppose we talk about a derivative of this compound, that is two carbons attached together through a single covalent bond, and to one carbon there is attached one chlorine. Now what will happen, that all the other bonds being non-polar, just like the previous example, here is one bond that is between carbon and chlorine. Its electron density will flow more towards chlorine as compared to carbon. So we say that this is a polar bond. Because of the polarity of this bond, what will happen, that this chlorine is having a partial negative charge and this carbon a partial positive charge. Now this carbon, while it's having partial positive charge, is further attached with 3 more atoms, 1 carbon and 2 hydrogens. What about these bonds that it's making with these hydrogen and carbons and carbon? We expect that when it acquires a positive charge, it means it's now having a deficiency of electron. So it will start making up its electron density by attracting the electronic cloud of those bonds that it's making with other atoms. Because the electronegativity, we are considering that carbon-carbon electronegativity, this is exactly same, whereas the bond between carbon and hydrogen, this is non-polar, so it means although there is electron density difference, electronegativity difference, but hydrogen is a donor atom as compared to carbon when it comes to electron density. So this electron density will flow towards this electron deficient carbon. Similarly, this electron density will flow towards carbon, and this one will also flow towards carbon. But remember that the amount of electron density that will flow from these two hydrogen and carbon, it will be lesser flow as compared to when it flowed from carbon towards this chlorine. So we can say that this positive charge will not be finished, that is, it will not diminish by the even though the electron density from these atoms is flowing towards carbon, this carbon will be having still a partial positive charge, because this electron density from these sigma bonds, it will not flow in such a greater amount that the positive charge could be completely finished up. So But even then, when this electron density flows towards this carbon, what will happen to these three atoms? Now, these atoms, they will be experiencing some deficiency of electronic cloud, so they will be acquiring partial positive charges. What do we mean by this partial positive? Partial positive means this is fraction of positive. When we have double partial, it means this is a fraction of fractional positive. That is, it's smaller as compared to this partial positive charge. Similarly, this hydrogen, it will have a partial positive, and this carbon will also have a partial positive charge. So when this carbon acquires this partial positive charge, it means it's also now having a deficiency of electron, not as much as this carbon is having. So it will start attracting electronic cloud from the nearby atoms that are attached to this carbon. But this attraction of electronic cloud will not be as much as it was in the previous cases. But even then, there is electron density flow from the attached hydrogens towards carbon. Now what will happen to these hydrogens? In turn, these hydrogens will also get a positive charge, but its value will be further smaller. So it will be partial positive. So here partial positive, partial positive. So now these partial charges that have been created over all of these regions of this molecule, what is the reason for this? We say that this bond, that is the polar bond, this is responsible for creating polarities over other bonds. So this induced polarity that has been created because of this polar bond, this is called the inductive effect, and it always travels from this polar center towards the other parts of the molecule, and always it travels through these sigma bonds. By sigma bonds we mean these single bonds that are between carbon and carbon and hydrogen. So this induction of this polarity because of a polar bond, this is an important factor while we are discussing the organic molecules, because the different parts of molecules, they will be showing somewhat unpredicted behavior whenever there is a polar bond inside the molecule. So one thing has to be remembered here, that while we are talking about this molecule, in such cases, um, the total amount of the charge, for example, we are having two centers. One is the negative one, and the other one is the positive one. So the total amount of this partial negative charge will be equal to the sum of the all partial positive charges or the other parts of the molecule. That is, the total charge will be over a neutral molecule will be zero. So this partial positive charge over this carbon, this will not be exactly equal to partial negative charge over this chlorine. Rather, this will be smaller, and to as much amount as is the total charge over all the other atoms that are feeling this partial positive charge as a result of this induction of the charge. Similarly, one thing more that has to be understood and remember about this inductive effect, this is that this effect becomes weaker and weaker as we move away from the actual polar bond. So it will be smaller when we move, for example, to these bonds as compared to this bond. And it has been estimated that inductive effect normally operates up to four covalent bonds, and beyond four covalent bond it becomes zero. As well as more thing has to be remembered, that the amount of the charge that is created, this depends upon the group. That is, for example, an electron attracting group. If some strongly electron attracting group is there, for example, if there is some nitro group or cyano group, the amount of the partial negative charge created, this will be larger. So its effect that the other parts of the molecule will feel as in the form of partial positive charges, this will be larger as compared to, for example, chlorine, bromine or other groups.